Okay, we're looking at factoring part 2 and solving quadratics. We're going to look at a couple patterns here. Notice with these three examples here, I have x plus a number and x minus a number. This one I have x minus a number, x plus a number, but these numbers are the same in each pair. Well, here's what happens when I FOIL out the first one, and when I simplify it, this minus 2x and plus 2x cancels each other out. So I'm just left with x squared minus 4. Now in the second one, when I use the 8s, I have 1 plus and 1 minus. When I combine like terms, that plus 8x and minus 8x cancels out to be 0, so I'm left with x squared minus 64. And now when I use the 7s, 1 plus 7 and 1 minus 7, those middle terms end up being minus 7x and plus 7x, which cancels out to 0. So this one would simplify down to x squared minus 49. Now if you look at each of these answers, they've got some things in common. First of all, there are only two terms. Most of the time when we FOIL things together we get three terms, but for this particular setup you'll only get two terms. The next thing that hopefully you're noticing is the 4, the 64, and the 49 are all very special numbers, and the reason that is they're perfect squares. The square root of 4 is 2, the square root of 64 is 8, and the square root of 49 is 7. Now if you look at the 2, the 8, and the 7, those tell us the numbers up here in our parentheses, a 2, an 8, and a 7. The other thing that's special about them is the x squareds are all perfect squares, because the square root of x squared would just give me an x. So for each one of these, I would have an x, an x, and an x. Notice that that's the first part of what I have in my parentheses. So this is a special pattern for factoring, and it's called the difference of two squares. So go ahead and get your flip books out, go to the two-term column, and go down to the tab where it has a squared minus b squared. Now open up that tab and we are going to write down our pattern. So on your flip books, go ahead and write down that a squared minus b squared is equal to a plus b and a minus b. Okay, we're going to do a couple examples. The first two go in your flip book. So on that same tab, go ahead and put down example 1. And we're going to use x squared minus 64. Well, now if you think of what our pattern says, it says we use a squared minus b squared is equal to a plus b times a minus b. Notice each of these has a square on it. Well, my x has a square, but my 64 doesn't have a square, so it doesn't really look like it matches the pattern. But what we can do is we can rewrite them, and I recommend that you always rewrite it first, because you're less likely to make mistakes that way. So you want to ask yourself, what can I square to get x squared? Well, that would be an x. Then, what can I square to get this 64? That would be an 8. So I have now found what my a and what my b are. So my a is x and my b is 8. So when I factor this, I end up with x plus 8 times x minus 8. And we have it factored. Okay, this next example, put this down as example 2 in your flip books. We've got 49x squared minus 1. Now my hints that it might follow this pattern would be that 49 is a perfect square, x squared is a perfect square, and 1 is a perfect square, and I have a minus sign, because remember it's the difference of two squares. It has to be a minus sign. So I'm going to go ahead and try to rewrite this as a squared minus b squared. So I ask myself, what can I square to get 49? Well, that would be a 7. What can I square to get x squared? That would be an x. Then go to the next one. What can I square to get 1? Well, that would be a 1. So now if I go ahead and follow my pattern of a plus b, a minus b, I'm going to factor this into 7x plus 1 times 7x minus 1. And I would have it factored. So these patterns are like shortcuts that you can use for factoring. Okay, here's two more problems that we need to factor. Now this first one, As I look at that, I know I can't use my shortcut because it has 3 terms, and my shortcut is only for when I have 2 terms. So my next option is just to regularly factor it. I can't pull out any common terms because remember that's the first thing that you have on each column of your flipbook is to try to pull out a common term. So I'm just going to go ahead and try to regular factor it. I look at my x squared and that tells me I have to have an x and an x. Then I look at my plus sign on the very end and that means my signs match. I go to the next sign and that means they match as minus signs. Then I want to look at my factors of 25, which are 1 and 25, 5 and 5. Got to try to get them to add up to be this 10, so I'm going to use the 5 and the 5. Now when I FOIL this out to check it, I'm going to have x squared minus 5x minus 5x plus 25, and that would give me x squared minus 10x plus 25. Compare that to what I started with, and it matches identically, so we've got it factored on our first try. Now this last one, as I look at it, it doesn't match my shortcut because it has 3 terms, so I'm just going to have to try to factor it regularly. But I notice that I can divide all of these numbers by 2. So I'm going to go ahead and pull that 2 out and set it in front and be left with x squared minus 9x plus 14. That makes my numbers a little bit smaller and a little bit easier to work with. Now the 2 doesn't go away. It still sits out here in front, but we can kind of ignore it for the time being. So now I want to look at my setup here. This plus sign in the back means they match. This middle one means they match as minuses. So I'm going to have x minus and x minus. Now my factors of 14 are 1 and 14, 2 and 7. The ones that'll get me to this 9 in the middle are my 2 and my 7. So I'm going to go ahead and plug my 2 and my 7 in. I'm going to FOIL those together, so I'm going to have x squared minus 7x minus 2x plus 14, and that gives me x squared minus 9x plus 14. I still have the 2 out in front. It hasn't gone anywhere. So multiply that 2 back in, distribute that 2 in, and I have 2x squared minus 18x plus 28. Compare that to my original problem and it matches, so we have got it factored. Now that 2 out in front is part of the factored problem. It doesn't go away, it still is there. Okay, our next part, we're going to see if we can find another special pattern. And we're going to start with x plus 3, that quantity squared, which really means x plus 3 times x plus 3. And we end up with x squared plus 6x plus 9. So what I want you to do is look at this 3 that we start with and see if you can find out how is it related to the 6 and the 9. Here's an example with x minus 4, but still a quantity squared. It means x minus 4 times x minus 4, and when we FOIL it out we get this. So ask yourself, how is this negative 4 related to the negative 8 and the 16? And one more. We have x plus 7 squared. When I FOIL it out, I get x squared plus 14x plus 49. So ask yourself, how is this 7 related to the 14 and to the 49? Okay, hopefully you noticed that this middle term was 2 times whatever number you had. So 2 times 3, 2 times 4, 2 times 7. And this last one is your number squared. 3 squared is 9, 4 squared is 16, 7 squared is 49. This is also another special pattern that we're going to add to your flipbooks. This one is called the perfect square trinomials. So in your flipbooks, under the 3-term column, go ahead and find the tab that has this pattern on it. A squared plus 2ab plus b squared. Okay, on that tab, you're going to write down that a squared plus 2ab plus b squared is equal to a plus b quantity squared. So you should have this whole equation written on that tab. And it's called a perfect square trinomial. Trinomial indicating we have 3 terms. in the perfect square indicating that our first term is perfect and our last term is perfect. Okay, I've cleared the screen, and go ahead and put down example 1 on your flip books. We'll probably only be able to fit one example on this one. So what we're going to do for our first example is we are going to try to factor, let's do 16x squared minus 24x plus 9. So now as I'm given this problem and I'm asked to factor this, I can factor this without using the shortcut, but the shortcut can sometimes help us factor it quicker. So the first thing I want to check is, can I pull a common term out? And there isn't anything that I can divide 16, 24, and 9 all by. But then I notice that I've got a perfect square in front and a perfect square in back. So that's a hint that it might be the perfect square trinomial pattern. So what I want to do first is I want to rewrite this in terms of a squared and b squared. So I have to ask myself, what can I square to get 16? Well, that would be a 4. And what can I square to get x squared? That would be an x. Then I come to the back and I ask myself, what can I square to get a 9? And that would be a 3. Now, in order for this to work, I have got to check, is this middle term equal to 2 times a times b? So I'm going to plug those numbers in. Do I have 2 times 4x times 3? Now when I multiply that, 2 times 4 is 8, times 3 is 24, and an x. So now I have to compare. Did it work out is what we have to decide. When you look at this, you see we get a positive 24, but our problem wanted a negative 24. That's okay though, because if you look back at our examples up here, when I had a negative for that middle term, all that happened was I had x minus my number instead. So since we got the right number but the wrong sign, we're still going to be okay. So when I use my shortcut, I'm going to write it as the a minus b quantity squared. And the reason I'm using the minus is because I wanted it to be negative on that middle term. So I will have 4x, which is my a, minus 3 quantity squared. And that would be factored for our example 1. Now keep in mind, if you don't remember these shortcuts, you're still going to be able to factor it out the regular way. It might just take a little longer.